We're here today with Larry Cruchon, who is a risk and reliability engineer at the Nuclear Regulatory Commission, and Robert Hunsiger, who is an independent journalist. And I'm Dale Walkinen. I am a part of the Facing Future team. Welcome to both of you. We'd like to start probably with you, Larry, and you have a lot of experience. You're still at the NRC. You've had some complaints that you've issued in the past toward the NRC and have had some difficulties with them. We'd like to understand a little better how the NRC operates in terms of whistleblowers. So maybe you can start.
Yeah, I guess the major issue I was involved with was flooding at nuclear power plants.
Mm-hmm.
About 5 years at least prior to Fukushima, the NRC became aware that the Coney nuclear station outside of Clemson, South Carolina, is susceptible to a Fukushima style accident. Of course, in 2006, you wouldn't have called it that because Fukushima hadn't happened yet. But some the resident inspectors at the plant had questioned the requirement for the flood wall around the plant's safe shutdown facility. And at Coney, what the safe shutdown facility was it was a building that housed the equipment needed to safely shut down the reactor plant. And the concern was that the height of the flood wall around that facility was 5 feet tall. And the resident inspector had found a report that Coney Nuclear Station had done for FERC, the Federal Energy Regulatory Commission. Mm-hmm. And I'm sorry, I said a Coney Nuclear Station. It was actually Duke Energy. Duke Energy owned a Coney Nuclear Station, but they also owned the Lake Jocassee Dam. And the Lake Jocassee Dam is a pump storage dam. So when electricity prices are high, they drain water from Lake Jocassee into Lake Kewah. And at night, when electricity prices are low, they pump water from Lake Kewah back up to Lake Jocassee. Well, Duke Energy had to do an estimate for the Federal Energy Regulatory Commission, FERC, who they're the ones who regulate power producing dams. They had to do a report, saying what would be the result if, your dams break.
So we're hoping this dam is below the plant.
No, it's upstream.
It's upstream of it.
Yeah.
Okay, so therein lies the problem. Is that correct?
So they as part of that report, they predicted a flood height of, I think, 18 feet at Coney. Uh-huh. So above grade.
Yeah.
And well, if you got a 5-foot flood wall around the safe shutdown facility and you have a 18-foot high wall of water, that's going to overtop the flood wall. And from there, the scenario is similar to Fukushima. So in 2006, the resident inspectors find this. In 2007, there's some back and forth between the regional office in Atlanta and Duke Energy. And in 2008, maybe it was late 2007, NRC headquarters got involved.
Now, I'm confused. Why would they have a dam that has only a 5-foot wall when they know that, why have a plant with only a 5-foot wall?
That's a good question. Their analysis, I think it was done in the 1980s. It might have been earlier. But their analysis they did before building that flood wall was what you might call a static analysis. So you would say, if this dam were to break, the downstream valley has a certain a certain topography, ability to absorb the water, how high would the water get? And the answer is, I think it was 4.71 feet. So a 5-foot flood wall is adequate. But by the 1990s, our ability to model flooding had improved, and you did a more dynamic analysis. So you realize that, you know, when the dam breaks, water doesn't just easily, you know, disperse in the valley below. It rushes down in the form of a wave. And
so when this was understood, why wasn't the wall raised? What was?
Oh, that's a good question. I think there's two reasons. One is money. It's easier to fight this thing with your pencil than actually spending money to improve safety. When you change the topography by building walls around the plant to protect from flooding from a dam, you reduce the ability of that plant to drain water from what's called a PMP, a probabilistic maximum precipitation event. So, so I guess you're protecting by building more flood barriers. You're protecting against a dam break, flooding from a dam break, but you also make yourself more risk of flooding from a PMP.
What is PMP?
Probabilistic maximum precipitation event.
Okay, so it would hold in the water from rainwater.
Yeah, so
it would be held into the plant.
What a PMP is you've heard terms like
drain. I mean,
yeah. Well, you've heard. Well, that's the other thing is if you put drains under your flood walls, that's another source for the flooding water to come in from the dam break. So you need the drain to drain the rainwater, but
you can open and close, perhaps. You know, I mean,
this is you're right.
For power plants, really, they can figure it out.
You're right, but that was the explanation that was given to me why they couldn't just raise the flood height. But I think the real explanation was they just didn't want to spend the money,
the cost.
But the PMP is kind of important to understand. Are you familiar with terms like the 100-year flood line and the 500-year flood?
Yes.
Yeah, so that's the 100-year flood would be the flood that has about a 1% annual probability of occurring. So in any given year is about a 1% chance that a flood would happen at that line. The PMP is similar. You know, you have like the 100-year PMP. Well, I guess the PMP would be the maximum, but you do have you have precipitation events that you put a probability to them. So,
but you're finding that all of these things, the 100-year storm, the 100-year flood, are totally irrelevant in the face of climate change, that everything is changing so rapidly that, we can't use those same measures that we used to use reliably because we're looking at much more serious environmental.
Well, it is true that if you have 200 years of historic data and then you raise the ocean temperature by 1 degree Celsius, your 200-year data isn't under the same conditions. So yes, right. If you have 100 years of data or 200 years of data, and there's very few places we have more than that, that's probably good data for calculating the 100-year flood. But what if you want to calculate the 10,000-year flood? I mean, we don't have 10,000 years of data anywhere, right?
Well, in some cases, but not so
right.
Nuclear issues, which has only been a problem for a certain period of time. I mean, we've created something that we don't really know how to deal with, and we don't really know how to deal with the waste. I mean, even if you listen to the higher ups from NRC, they're saying, well, we've got them in canisters, but we have to put them somewhere eventually, and we haven't got a place to put them, and we don't know what to do with it. And this stuff lasts 100,000 years.
Right.
Who's going to be around to deal with this stuff?
Right.
And we've put it there. So we keep making this stuff, and we don't know what to do with it.
Right.
And the NRC, it seems to me, it's it's supposed to be our agency that protects us from the risks that are involved in the industry itself, and yet it seems to respond to the industry.
Right.
When the industry asks for relief, we don't want to insure this, or we don't want to have inspections, or they're able to do that. Whereas when the public presents a petition, like you as a private citizen presented a petition, it was very hard for you to be heard and to have that go through. I wonder if you could talk a little bit about that process.
So we tell Duke Energy, we're just like, well, we want a new estimate on, what's going to happen if that dam does fail. And they got back to us, and their answer, and keep in mind, this is in, I think it was September of 2008. So this is 2.5 years before Fukushima. Mm-hmm. Their answer was early similar to what happened at Fukushima. They basically said that, the dam breaks within like so many minutes, the flood wall at the safe shutdown facility is overtopped. And it was something like maybe it took an hour for the flood waters to get there, because this plant is 12 miles downstream of the dam. But then within 9 hours, the fuel would start to melt. So you'd have a core meltdown at all three of the reactors. And then within, I think it was 67 hours, the containment buildings would start to fail. So now you've melted down the cores, and 67 hours later, you're losing containment. So this is pretty much the timeline at Fukushima. At Fukushima, it wasn't a dam break, it was tsunami, but a tsunami overtopped the flood wall. The plants shut down. The cores started to melt about the 9-hour range, and the containment buildings, you started seeing them exploding about, right around the 3-day mark. So it was very similar. Now the big difference is, this is outside Clemson, South Carolina, which I'm sure you're aware is not on the ocean. At Fukushima, the prevailing winds blow out to sea. And during the Fukushima releases, the prevailing winds typically blew the fallout into the ocean. But there was an amount of time, maybe 15, 20% of the time that the winds were blowing it on land in Japan. And that's why you have such a high contamination rate in certain areas of Japan. And a lot of the land is, they had to move people off of it. Well,
if there was a radiation event, it may not be as large an area, but it would certainly be an area. And
yeah, well, but at Clemson, South Carolina, that fallout cloud has about 200 miles to go before it hits the ocean. If it hits a rainstorm in between, it can you can have a fallout issue really anywhere along those 200 miles, depending on the weather event.
Yeah.
How much, I don't understand the vulnerability of those canisters. I think the issue is that nobody does.
Right.
I think that's the issue, as I understand it. Nobody can answer that question. How much overheating can those canisters take is the question, is it not?
Yes.
And how much temperature could it create? Now, they claim it has 800 Fahrenheit degree maximum capacity, and that it's currently 500 degrees as it sets there in its spot. And then the exterior of those canisters, they say, is 400 degrees Fahrenheit. So if you got the flooding, and I have no idea how rapidly that temperature could crank up to what degree, but if it goes over 800, it's going over the maximum they claim it can withstand. Would it go over 800? Do we know? Is there any way to know that?
It depends on what the fuel load is, or what the heat load of the fuel is.
Okay.
Yeah, and that's really based on how old the fuel is, the spent fuel is in there. But the flooding isn't a concern when it's in the water. What the flooding concern is that water that gets in that canister will bring with it things like sand and mud and stuff like that. And then when the water recedes, you have this canister that was designed, you know,
for airflow
with channels in certain spots that are now clogged with sand or mud.
Exactly.
You know, you wouldn't. So just to be clear, the flooding's an issue, but the issue is what happens after the water recedes, as I understand it. So
yeah.
Well, what does happen? How do we deal with this problem? We keep making more nuclear waste, and we don't have a place underground to put it. We have these overground storages.
Right.
We have to keep it safe for how many 100,000 years, perhaps? You know, this is a problem that, you know, humanity has never dealt well with its waste, and civilizations have fallen because of the failure to know what to do with waste products. And now we have this waste product from nuclear energy, and we don't know what to do with it, really. We think, well, if we could put it in a mountain, but nobody wants it, we don't have a safe place to put it. And it's everywhere there's a plant, there's this stuff. So it's concerning to all of us human beings that these things are you know, a clear and present danger to our well-being. Is that?
Well, yeah. I mean, I think there's solutions, but no one wants to spend the money doing them. So.
Okay, well then we have a problem.
Right, we do.
Then we got a problem.
Right, right. But to me, it's always been more of a political than a technology.
You think with the right money and the right political mindset, this can be solved?
Yes.
Okay.
Yeah,
and that would be
a
deep underground cavern, or what?
Well, no. The original plan was that we'd store stuff in the spent fuel pools for about 25 years or so, and then we would reprocess it. And when you reprocess the waste, you take the amount of, you take a ton of waste and you get all the usable uranium and plutonium out of them and the usable industrial isotopes. And, before you know it, you've knocked down the volume and weight of that waste to about 10% of what it normally is. Mm-hmm. And then the other piece of that plan was certain isotopes, certain long-lived isotopes, you could mix in with fuel in another reactor, and they would get neutron activated to something that has a shorter half-life. So the original plan for the waste was really an industrial plan. It was to reuse spent fuel and to kind of burn out the more longer lived.
Well, they do that in France, right? They reprocess.
Yeah.
Why don't we do that here? Why do we not reprocessing?
In the 1970s, Jimmy Carter basically made it illegal. And the rationale for that was when you reprocess spent fuel, the most useful component out of that is plutonium. And you can use that plutonium, like they do in France, to make reactor fuel and make electricity. You can also use that plutonium to make a nuclear weapon. And in the 1970s, Jimmy Carter was trying to convince a lot of non-Western countries that they should not be developing nuclear weapons. And one of the arguments against him was, well, the U.S. reprocesses spent fuel. What right do we have to tell other countries that they can't do that?
So at that point, we were reprocessing fuel. That was actually happening. That was the way it was working.
Well, it was happening on two levels.
Uh-huh.
Since 1944, our government had been doing it to make plutoniums so we could build weapons.
Right.
But in the 1970s, not only was the government doing it, but private companies were doing it to get plutonium to make reactor fuel. So, Jimmy Carter put a ban on reprocessing fuel in the US, and it was basically as a goodwill internationally.
Mm-hmm.
Well, imagine you're a company that's invested in reprocessing and all of a sudden it's illegal. Well, you shut down your operations.
Were there a lot of operations at that point that were?
I think there was a couple companies involved. It's been legal ever since the early Reagan years, but we haven't had anyone try to reprocess fuel since then. And
the alternative is to store it, and
right,
we have a good place to store it, because as long as we're keeping it above ground, it's a problem.
Right.
But reprocessing seems to me to be somewhat of an answer, is it not?
Yeah. It is. It's
well, isn't it awfully stupid? We're not doing that. What's the issue here? I mean, this just sounds absurd to me.
Yeah, it's absurd to a lot of people, but different people have different worries, and I guess the reason we don't reprocess is there's some worry about nuclear proliferation, and I'm not concerned about that in the sense that the countries that are going to go down that route are going to do it whether we reprocess fuel for commercial power or not. Mm-hmm. But there's others who think that we have a moral imperative not to do it because, if we're doing it, how can we tell Iran not to do it? How can we tell North Korea not to do it?
Well, it seems like the moral imperative is to provide the safest possible situation for using that material.
Yeah. So you would think that generic issue is going to get some high priority in the agency. All right. It took a year for it to get through review, and all the delays were because of security concerns. At the NRC, we have these reports called Safety Evaluation Report, an SER. Mm-hmm. And what an SER has traditionally been is it's looking at a license amendment or some type of safety issue. And traditionally, they're signed by someone, okay? And maybe they're signed by more than one person. But you have someone who's personally willing to put their signature on a report. They are answerable on a professional level to what they sign, all right? And normally, the flooding issues like Oconee were looked at with a safety evaluation report. And the safety evaluation report for Oconee, the one that was done in 2011, I think, that basically said they had to protect the plant, I think, to a flooding level of 12 feet. It might have been 18 feet. I can't remember. But the point is it's higher than 5 feet, okay? So you have to protect the plant to a certain flood level. Signed by two NRC employees. One of them was like a PhD in geology or hydrology or something. I can't remember the background of the other guy. But anyways, they're signed by two NRC scientists, safety evaluation report. Protect the plant to 12 or 18 feet of flooding, okay? Well, JLD starts closing out these flooding concerns at the plants, what's called a staff assessment, all right? What a staff assessment is whatever they want it to be. There's no management directive that defines it. There was a writer's guide for them, but it was basically, that was like a style guide. It wasn't any technical guidance on what to look for to bless off these staff assessments. Mm-hmm. And the other key is they're unsigned. No one knows who blessed it off. Your boss says, look, you get this done, or, it's going to impact you. Well, hell, why not get it done? Your name's not on it. I mean, you know, if you give these to the wrong people, don't make them sign them. They'll accept anything, and that's more or less what happened. A lot of them kind of accepted it under protest. You know, they really felt they were pressured, but at the end of the day, you have to pick the battles you fight. And unfortunately, there was several people who were doing that work who didn't want to join us in complaining to the Office of Special Counsel. And some of us made an Office of Special Counsel complaint about the way the flooding stuff was being handled.
So this Japan Lessons Learned Committee eventually put forth some recommendations, and I guess, were they followed? Or were they stymied by the industry lobbyist who was...
They were watered down.
The NRC.
They were watered down.
Watered down,
Yeah, and you got to remember too, when you're talking about watering something down, you could have a 100-page document of requirements and all sorts of stuff. You can take that from 100 pages of mandatory requirements to 100 pages of optional requirements just by inserting a single word in a well-placed sentence.
Then, Larry, the flooding issue is not resolved.
Exactly.
Correct?
Right.
Is it close to being resolved?
No, when you say not resolved
anywhere.
No, it's not even close. When you say not resolved, I mean it's every bit the risk it is today as it was in 2012. So it's not resolved.
In spite of Fukushima,
right.
We still haven't got the scent
right.
in this country.
Right.
Okay.
But in terms of the other definition of resolved, the NRC closed them all out. I mean, you know, they paper resolved it.
Paper resolved it. But in practice,
that's correct.
It's still there.
Right. Yeah.
So, all right.
It's terrifying, really.
Yeah.
Such
yeah.
a serious...
That sounds like a bunch of incompetence to me.